Hello guys, I'm here to assist you, help you to solve this equation that reads the following is a nuclear equation for a fission process resulting from the reaction of neutron with uranium nucleus. Here is the equation, and then you're supposed to determine the values of x and y. Part B or part 2, you're supposed to state the sources of energy released, and then part 3, we are supposed to explain how this reaction is made continuous in a nuclear reaction. Solution: we can write the equation that we obtain 141, then 56, this element A, plus y, then x, this is element q, and then we are also producing 3 neutrons. So with this, what we are supposed to understand is that we consider the superscripts alone and also consider the subscripts on their own. So on the reactor side, they should be equal to the product side. So in this side, for the superscript, we have 1 plus 235. This is giving us 141 plus y plus 3 neutrons. So we have 3 into 1. This gives us 1. This is 236 equal to 141 plus y plus 3, which is 236 equals to 144 plus y. So we can take this one on the other side, so that we have 236 minus 144 equals to y, and this gives us y equals to 92 by 36, 92. That is the value for y. To obtain the value for x, now we consider the subscript, whereby we have 0. So for y we have 0 plus 92. This one is giving us 56. 56 plus x plus 3 into 0. So this is 92 equals to 56 plus x plus 0, whereby 3 multiplied by 0 we get 0. So we have 92 equals to 56 plus x, which we can say 92 minus 56 equals to 90. That is 92 minus 56 is equals to 36. So we find that the value of x is equals to 36. So we can now we can give now the full equation as 1 0 plus 235 92 uranium reacts to give 141 56 A plus 92 36 Q plus 3 neutrons. Now that is now the equation we obtain after reacting. Remember, when we talk of fission reaction, elements break to form heavy elements, break down to form lighter ones, whereby in this case, when we combine these two, that is a neutron plus uranium, we get an element A plus an element B, Q, Q, and then we have three new particles of neutrons. That is for part 1. For part B, we are told to state the source of energy released. Now, the source of energy released in this case, this is what we call, remember, we get energy when these two are formed. So this release of energy is from what we call binding energy. Binding energy whereby binding energy is simply the smallest amount of energy required to remove a particle from a system of particles. So when we break this one, that is uranium, into two particles, we obtain that energy, and that energy that was holding these two into uranium, that is what we call binding energy. Then part 3, we are asked to explain. We're supposed to explain how these reactions is made continuous in a nuclear reaction. Now, when you look at how the reaction is, whereby initially we had just one element, which is uranium. We reacted it with a neutron, and then we have managed to obtain two elements. So you realize that these two elements, they can still react, and we say that nuclear fission occurs with heavier elements, where the electromagnetic force pushing the nuclear apart dominates the strong nuclear force holding it together. Now, in order to initiate most of these fission reactions, an atom is bombarded by a neutron, as we have seen that uranium is bombarded with a neutron to produce an unstable isotopes. We can see the two unstable isotopes, that is which undergoes fission. Now, when these neutrons are released, remember we have an extra neutrons released. Initially, we applied one neutron atom to bombard this atom of uranium, but in the product side, we have managed to obtain 3 particles of neutron. So these particles here, the product on the product side, they are able to bombard other. They can bombard these reactions to proceed to continue reacting. So for us to maintain this reaction, we have said that these isotopes are initiated by the produced neutrons, which sustain the reaction. So as long as there is this bombarding neutrons, these two will continue breaking down into new atoms until that is infinity. So we will not have the reaction will not end, will continue to the end. So in short, we are saying that the last produced protons are the ones that are used to keep the reaction proceeding. So I wish you all the best.